integrals. One is algebraic, or one is trig. So it's nice to practice this type where it is a quotient, but we know we can't integrate quotients. We can only integrate sums and differences. So we're going to have to split this up. So here we go. And remember, you can split it up as long as there's one term in the bottom like this. So we have x to the fourth over x to the fourth minus 3x squared over x to the fourth plus 5 over x to the fourth. All that with respect to x. Now, you're probably going to get used to not really noticing this, but this has to be with respect to x. For us to integrate this, I forgot my x here. So now we're going to simplify. We have 1 minus 3x to the negative second plus 5x to the negative fourth. Now we have it in form that we can actually find the antiderivatives or integrate. So the integral of 1 with respect to x is x. The integral of 3 to the negative second would be add 1 to the exponent, multiply by the reciprocal, or negative 1. So that would be negative 3 times a negative 1. The last term, add 1 to the exponent, multiply by negative 1/3. So now this is minus 5/3. You can factor out a x to the negative 3 over 3 like we did it in differentiation. I'm just going to get rid of the negative exponents and add my plus c. So I checked with Wolfram Alpha, and you can see that that's the correct answer. Now, if you did factor out a 1/3 x to the negative 3, 1/3 x to the negative 3, you would have gotten 3x to the fourth plus 9x to the second minus 5, I believe. So you would have gotten one single term. So there you go. And the next one is a trig one. Trig ones are pretty easy because there's not much you can do. You already know the trig derivatives, so the only integrals you can get are those that are results from derivatives. So in other words, if you're looking at this function and the trig parts of this function, you should notice that we have a secant squared. We know there's a trig function whose derivative is secant squared, so this is very doable. If there was just a secant, we'd be in trouble because we don't know any derivatives that turn out to be exactly secant. So this is just knowing your derivatives and being able to work backwards. Also notice the variable here is theta, so there is a d theta. Those have to match. So the integral is secant. You just have to remember that the derivative of tangent is secant squared. So that means the integral of secant is tangent. Notice there was nothing I really had to do here as far as rewriting because this is all sum and differences. So I can just integrate straight across. The integral of sine, well, you can either think of it this way. The integral of sine is negative cosine because derivative of cosine is negative sine. Or you can think of this as just integrating negative sine, and that would become positive cosine. And then the integral of 3 theta, theta is just like an x here. So that would be add 1 to the exponent, theta squared, and then multiply by 1/2. And we are done as soon as we put that finishing touch, which is the plus C. And I also checked this on Wolfram Alpha. And again, they reversed the terms. They put the algebraic term first, as that you usually would, but we have that plus cosine theta plus tangent theta plus constant, and that looks good. So that's it.